You are welcome to today's course. In today's course, we are going to look at the law of conservation of mass. This law has to do that matter cannot be created or destroyed in a chemical reaction. Matter cannot be created or destroyed in a chemical reaction. This actually happens basically in a closed system. It means that the mass of the reactants before a reaction must be equal to the total mass of the products after the reaction. And when a reaction takes place, could be physical, could be chemical, that the mass, if you measure the mass before the reaction, after the reaction, you measure the mass of the reactant must be equal to the mass of the product. For instance, in a combustion reaction, we maintain bonds in oxygen to give us CO2 plus H2O. It's a combustion reaction. Okay, so now let's balance the equation. In here, the reactant will have hydrogen to be 4. So we put here, hydrogen becomes 4. 2 times 2 becomes 4. So in the product, we already have oxygen to be 4. So if we put 2 here, oxygen will be 4. Is that okay? So it's now a balanced equation. So you know that they maintain this side. This is what we call the reactant side. Reactant side, or the reactants. This is the product side, or the products. So the law of conservation of mass is telling us that if we measure the mass of methane and oxygen in a closed system, as methane CH4 and oxygen in a closed system, and they bond, that after the reaction, the mass of CO2 and water will be equal to the mass of the reactants before the reaction. Okay, now let's look at the reactant side. If we look at the number of atoms that took place, like carbon, let's consider carbon. How many atoms of carbon? 1 atom of carbon in the reactant side. How many atoms of hydrogen? 4 atoms. How many number of oxygen? 2 multiplied 2. That is also 4. Now let's look at the product side. How many number of carbon? So only this. So 1 atom. Hydrogen, 2 multiplying 2. So hydrogen on the reactant side is 4. How many oxygen? How many atoms of oxygen? You can have 2 here and also have these 2 because you're going to multiply this. So you're having 4 atoms. If you look at both the reactant and the product side, you will discover that the atoms are exactly the same thing. Now let's look at this reaction in a different approach. that is methane, combustion of methane, presence of oxygen. So give us CO2 and water. We have 2 here. We have 2 here. So, if you bear in mind what the law of conservation of mass is talking about. Okay, so assuming we are told that 8 grams of methane combined with 20 grams of oxygen. 20 grams of oxygen. And after that the mass of CO2 that was formed is 15 grams. And we're asked to find the number or the mass of water in gram that is produced. Now, bearing in mind that according to the law of conservation of mass, the masses of the reactant must be equal to the masses of the products. So, if you say 8 plus 20, so in the reactant side, we have 28 grams. If we have 28 grams in the reactant side, it also means that we're going to have how many grams here? We're supposed to have 28 grams in the product side. Now, we are told that CO2 is 15 grams. How many grams of water was produced? What do we do? 28 minus 15. That will give us what? 13 grams. 13 grams of water was produced. If you sum up 13 plus 15, it will give us 28. So, it shows that it is balanced. Now, secondly, let's look at this question here. It said, when 50 grams of calcium carbonate, that is calcium trioxocarbonate, the general name is limestone. So when 50 grams of calcium trioxocarbonate is heated, it decomposes into calcium oxide and calcium dioxide, as carbon dioxide. If 28 grams of calcium oxide is formed, what is the mass of carbon dioxide released? Okay, solution. We are told that calcium trioxocarbonate, CaCO3, undergoes decomposition to give us Ca, calcium oxide, plus CO2. That's what the reaction is saying. They told us that 50 grams of calcium carbonate. This is what? 50 grams decomposed to give us calcium, 28 grams of calcium oxide. So 28 grams of calcium oxide. And we are asked to find the mass of carbon dioxide released. Can you see? It's simple. Bear in mind that the reactant, the mass of the reactant, must be equal to the mass of the product. So if here is 50 grams, it means that here also will be 50 grams. If here is 50 grams, as we are told, and we have 28 grams here. And here's the total of here supposed to be 50 grams. What do we have? 50, it now becomes 50 minus 28. And that's going to give us 22 grams of CO2 is being released. Yes. Then another thing you need to take note is that it shows that in a reaction, atoms are not lost. They are only rearranged. If you look at all these equations we've written, you discover that atoms are not lost when a reaction takes place. They are only rearranged in different ways. You can also observe this in rusting. You can also observe this in melting, like in the melting of ice. The mass of that ice, if you measure it after melting, you discover that it will be the same thing. In any reaction, chemical reaction, physical reaction that takes place, this holds. The mass of matter or mass is neither created nor lost during a chemical reaction. Thank you. This is the end of the class.